In example 2.34, the 13th term of an AP is 3. Thirteenth term of an AP is 3. Therefore, we represent the 13th term as T13, which is equals to 3, and the sum of first 13 terms is 234. Sum of first 13 terms means we will represent it as S13 is equals to 234. We need to find the common difference, which will represent it as D, and we need to find the sum of first 21 terms, that is S21. With these two hints, we have to find out the values of D and S21. So T13, in order to use the T13, we will use the formula of Tn is equals to A plus n minus 1 into D. Therefore, we are given with T13 is equals to 3. T13 can be written as using this formula A plus n minus 1 into D. Therefore, 13 minus 1 is 12D, which is equals to 3. This I will consider it as equation 1. We have used this hint and found the value as the equation as A plus 12D equals to 3. Next we will use this hint S13 is equals to 234. So S13 is nothing but we can use the formula n by 2 2A plus n minus 1 into D, which is equals to 234, and the value of n is 13. Therefore, 13 by 2 2A plus 13 minus 1 into D, which is equals to 234. 2A plus 12D, 13 minus 1 is 12D, 234. I am reciprocating this, that is taking it to the other side, it will become 2 by 13. Cancelling 234 with 13 will get 18. 2A plus 12D equals to 36. This will consider it as equation 2. Now what will we do is we have to simplify equation 1 and 2 using linear equations. First equation is A plus 12D equals to 3, and second equation is 2A plus 12D equals to 36. We will change the signs. 12D plus 12D minus 12D will get cancelled. Minus 2A plus A is minus A, which is equals to minus 33. Minus and minus will also get cancelled. A is equals to 33. Thus, we got the value of A. We will substitute in any one of the equations. We can find out the value of D. We will substitute A equals to 33 in the first equation. Therefore, A plus 12D equals to 3. A value we got it as 33 plus 12D equals to 3. 12D equals to 3. 33 if we take it to the other side it will become minus 33. 12D equals to minus 30. D equals to minus 30 by 12. Cancelling it in the third table, 10, 4. With 2 table 5, 2. Therefore, D equals to minus 5 by 2. So, we got the value of D. D equals to minus 5 by 2. Now, we have to find out S21. To find out S21, we have to use the formula Sn is equals to n by 2, 2A plus n minus 1 into D. So, S21 is equals to 21 by 2. 2 into A value we got it as 33 plus N value is 21 minus 1 into D value is minus 5 by 2. So next is S21 equals to 21 by 2 into 2 into 33 it is 66 plus 20 minus 1, 21 minus 1 it is 20 into minus 5 by 2. 10 times, therefore 21 by 2 into 66, 10 into 5, 50, we have minus symbol over here, it will become minus 50. 21 by 2, 66 minus 50 will give me 16, therefore cancelling it will get 8. So 21 into 8 it is 8, 16. Therefore S21, that is sum of first 21 terms is 168. So we have found out both the values of D and S21. In example 2.35, it is given as in an AP, first sum of first n terms is given, that is Sn value is given. We need to find the value of 17th term. So let us do so. We are given with sum of first n terms, which is represented as Sn is equals to 5n squared by 2 plus 3n by 2. Next is we need to find the 17th term, that is T17. This could be easily found out by using T17 equals to sum of first 17 terms. With this we have to subtract sum of first 16 terms. If we do this, so we can get the value of T17, that is sum of first 17 terms minus sum of first 16 terms will give me the 17th term in the series. Therefore, we will find S17 first. This can be found out by using the given Sn. If we substitute the value of n as 17, we can find out the value of S17. Similarly, if I substitute the value of n as 16 in this, we can find out the value of S16. This I will consider it as equation 1. So, n is equals to 17. I will substitute in equation 1. What will I get? S17 is equals to 5 into 17 square divided by 2 plus 3 into 17 by 2. 17 square it is 17 into 17, 49, 4, 11, 7, 1, 9, 8, 2. So, 5 into 289 by 2 plus 17 into 3 it is 21, 2 balance 51 by 2. Next is 5 into 289 will give me 45, 4, 40, 44, 4. So, it is 1445 divided by 2 plus 51 by 2. Both of the denominators are 2, so that we can directly add the numerators. 1445 plus 51 will give me 6, 9, 4, 1 by 2. So, 7 times, 4 times, 8 times. Therefore, S17 is equals to 748. By using the similar steps, we can find out the value of S16. We have found out S17 as 748. Now, we will substitute the value of n as 16 in equation 1. Therefore, S16 is equals to 5 into 16 squared by 2 plus 3 into 16 by 2. So, 5 into 16 squared it is 256 divided by 2 plus 16 into 3, 8, 48 by 2. So, next is 256 if I divide it with 2, 1, 2, 8. So, 1 to 8 into 5 will give me 40, 4, 10, 14, 1, 5, 6. 640 plus 24, because 48 by 2 it is 24. Adding this will give me 664. That is S16 is equals to 664. So, by using this formula, we can find out the value of T17. Therefore, T17 is equals to S17 minus S16. S17 value we got it as 748 minus S16 we got it as 664. If we subtract this 2, we will get it as 84. So, the value of the 17th term is 84. In example 2.36, we have to find the sum of all natural numbers between 300 and 600. We should not include 300 and 600 because it is given as between 300 and 600. We have to include only the numbers from 301 to 599. 300 and 600 is not included. which are divisible by 7. This is the hint given to us. Now what we have to do is, we have to find Sn, which is the formula as n by 2 a plus l. Now we have to consider the series by using the hint given. What we have to do is, we have to consider the numbers between 300 and 600 which are divisible by 7. So 301, it is divisible by 7. So 301 is included. 302, 303, all those things are not included. 308 is included because it is divisible by 7. Similarly, if we go in the same pattern, the last number within 600, it is 595, which is divisible by 7. So this is the sequence we have to consider, and we know the value of a from this, it is a is equals to 301, that is first term, and the value of L is 595, which is the last term. Similarly, we can find out the value of D easily because this divisible by 7. So the difference between these two numbers is 7. So D is equals to 7. Let us substitute in this. We will find out the value of Sn. So for finding the value of Sn, first we need to know the value of n. For that we can use the formula n is equals to L minus A by D plus 1. So n is equals to, L value is 595 minus A value is 301 divided by 7 plus 1. So 595 minus 301 will give me 294 by 7 plus 1. 294, when it is divided by 7, it is 42 plus 1. Therefore, the value of n is equals to 43. Thus, we have found out the value of n. We will substitute in this. We will find the sum to n terms. Therefore, Sn, that is S43 is equals to 43 by 2. Value of A is 301 plus value of L is 595. Therefore, 43 by 2, 301 plus 595, it is 896. We can cancel this. 448. We have to multiply 43 into 448. Therefore, 24, 2, 12, 14, 12, 13, 32, 3, 16, 19, 1 balance, 16, 17, 4, 6, 12, 1, 9, 1. So it is S43 is equals to 19,264. Thus we have found out the sum to n terms of the problem. In example 2.37, a mosaic is designed in the shape of an equilateral triangle. This is an equilateral triangle. What is an equilateral triangle is? It is of equal lengths on each side, and it is given as 12 feet on each side. Next, each tile in the mosaic is in the shape of an equilateral triangle, which means each tile in the mosaic is also an equilateral triangle, which means the length of all sides are equal, and it is given as 12-inch side. 12 inches we can write it as, which is nothing but 1 feet. So this represents 1 feet, and it is given as the side of this is 12 feet. One row represents 1 feet in the sense, therefore from this itself we can conclude that there are 12 rows in the mosaic. Next, what it is given is, the tiles are alternate in color as shown in the figure. In the textbook, the shaded region are in blue color, whereas this region are in white color. So we have to find the number of tiles of each color, which means blue color, number of tiles of blue color and number of tiles of white color. We have to find these two things, as well as we have to find out the total number of tiles in the mosaic. We will do one by one. So in the given problem itself, that is by the given figure itself, we can find out. We already found out there are 12 rows in the mosaic. Now what will we do is, number of tiles in white color. number of tiles in white color is, see, if you see in this, first row as one tile and the second row as 2 and the third row as 3, fourth row as 4, fifth row as 5, sixth row as 6, seventh row as 7. Similarly, it is numbered as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, each row as 1, 2, second row as 2 white tiles and third row as 3 white tiles, and accordingly 12th row as 12 white tiles. So, this is number of tiles in white color. Similarly, we will write it for the blue color as well. Number of tiles in blue color. In the first row, there is no blue color tile, therefore it is 0. In the second row, there is one blue color tile, therefore it is 1. And in the third row, there are 2. Similarly, if we proceed in the same fashion, we will get it as in the 12th row, we will get 11. So, with this data, now we can find the number of tiles in this mosaic which are all in white color. Let us find so. So, number of tiles in white color. So, it can be 1 plus 2 plus 3 etc. up to 12. Therefore, n value is 12. 12 by 2 into A value is 1 plus L value is 12. Therefore, 12 by 2 into 13. 12 into 13, 6, 3, 2, 1. 156 by 2. So, number of tiles in the white color in this mosaic is totally 78. In a similar fashion, we can find out the number of tiles in blue color. To find the number of tiles in the blue color, we will use this data. Number of tiles in blue color is 0 plus 1 plus up to 11. We have written it in the series. Therefore, number of terms is 12. Therefore, 12 by 2 into first term is 0, last term is 11. 12 by 2 into 11. 12 into 11. 132 by 2, it is 66. So, we have found out separately, that is number of tiles in the white color is 78 and number of tiles in blue color is 66, and also we need to find one more thing, total number of tiles in the mosaic. To find the total number of tiles, we have to add these two terms, that is total number of tiles is equals to number of tiles in white color is 78 plus number of tiles in blue color is 66. Adding this will give me 78 plus 66, it is 144. So, the total number of tiles in this mosaic, it is 144. Thus, we have found it. In the next problem, it is given as the houses of a street are numbered 1 to 49. So, numbers of the street numbered as 1, 2, 3 up to 49. Senthil's house is numbered such that sum of number of the houses prior to Senthil's house is equal to the sum of numbers of the houses following Senthil's house. Now, we need to find the Senthil's house number. Let us consider Senthil's house number as x. Okay, so the term before x will be x minus 1 and the term after x will be x plus 1. According to the given question, what can we write is sum of numbers of the houses prior to Senthil's house. Sum of house of the numbers in the sense 1 plus up to x minus 1, 1 plus 2 plus 3 up to x minus 1. So this is sum of number of houses prior to Senthil's houses, that is before Senthil's house, which is equal to sum of the numbers of the houses following Senthil's house, which means following will be after x, x plus 1 plus x plus 2 etc. up to 49, and this could be written as sum of terms to x minus 1. This can be found out by using sum of first 49 terms minus sum of x terms in order to find sum of x minus 1. Now we are going to use the formula of Sn for all these three terms, that is Sn is equals to n by 2 a plus l. So we are going to use this formula for all these three terms. So x minus 1 can be represented as, instead of n we have x minus 1 by 2 into a value in this it is 1 plus l value is x minus 1, which is equals to, for S49 it is 49 by 2, a value is, that is 1. 1 to 49 means a value will be 1 plus last term in this will be 49. Similarly, if it is sum of first x terms means it is x by 2, first term will be 1 and the last term will be x. Now we will simplify this. In this, plus 1 and minus 1 will get cancelled. The remaining term will be x minus 1 into x by 2, and here it is 49 into 50 by 2 minus, similarly here it is x into 1 plus x by 2. In both the sides we have the denominator as the same 2, which we can directly cancel it. Remaining we will simplify it. What will we get? X squared minus x, which is equals to 49 into 50, which is 9 fours are 45, 4 balance, 5 fours are 20, 24, 0. Minus, here it will become x into 1 it is x, x into x it is x square, and we have minus over here, therefore it will become minus x square. And minus x will get, we can cancel it, because minus x, if it comes to the other side it will become plus x, therefore x and x will get cancelled. X square, if I bring it to the other side it will become plus x square, therefore x square plus x square is equals to 2450. 2x square is equals to 2450. X square is equals to 1225. Taking square root on both sides it will give x is equals to square root of 1225, x is equals to 35. Square root of 1225 is 35. Thus we have found out the value of x, that is Senthil's house number is 35. Thus we have found it. Next is example 2.39. In this we have to find out, that is we have to prove that S3 is equals to 3 into S2 minus S1. For this we are given with sum of first n, 2n, 3n terms of an AP are S1, S2, S3. Therefore, first n terms means it is S1, first 2n terms means it is S2, first 3n terms means it is S3. We will write in such a order, then we can prove that S3 is equals to 3 into S2 minus S1. So, S1 is first n terms, and the formula of Sn is equals to n by 2, 2a plus n minus 1 into d. For first n terms it is S1, therefore S1 is equals to n by 2, 2a plus n minus 1 into d. This I will consider it as equation 1. If it is S2, then it is sum of 2n terms. Therefore, S2 is equals to 2n by 2, 2a plus 2n minus 1 into d. This we will consider it as equation 2. Similarly, if it is S3, it is first 3n terms. So, we can write it as 3n by 2 into 2a plus 3n minus 1 into d. This we will consider it as equation 3. And in this given equation, let us take the right hand side and prove the left hand side. Right hand side, it is given as 3 into S2 minus S1. We will complete the portions within the brackets first. So, it is S2 minus S1. S2 is the second equation, which is 2n by 2 into 2a plus 2n minus 1 into d, minus S1 value is the first equation, which is n by 2, 2a plus n minus 1 into d. We have to simplify this. Now, we will take this 2 to the brackets within the term. So, it will become S2 minus S1 is equals to n by 2 into this 2. If I take it to the this term, it will become 2 into 2, 4a plus 2 into 2n minus 1 into d minus n minus 2, 2a plus n minus 1 into d. Now, n by 2 is common in both the terms. So, let us take it outside. The remaining term is 4a plus this will become 2 into 2n, it is 4n d minus 2 into 1 into d, it is minus 2d. Similarly, we have taken n by 2 outside, therefore, the remaining term will be minus 2a. Next, it is minus n into d plus d. So, next it is, we have to simplify the term within the brackets. So, 4a minus 2a, it is 2a. Next, 4nd minus nd, it is 3nd. Next, minus d, minus 2d plus d is minus d. So, next it is n by 2, 2a, we will take d common in these two terms. So, it will become 3n minus 1 into d. So, this we got from S2 minus S1 is equals to n by 2, 2a plus 3n minus 1 into d. So, this we got from S2 minus S1 is equals to n by 2, 2a plus 3n minus 1 into d. In the left hand side, we have 3 as well. So, let us multiply it. If I multiply 3 to the left hand side, we should also multiply it to the right hand side. Therefore, 3 into S2 minus S1 is equals to 3n by 2, which is into 2a plus 3n minus 1 into d. Therefore, 3 into S2 minus S1, which is equals to, this is nothing but equation 3, which is S3. Thus, we have proved the given equation. S3 is equals to 3 into S2 minus S1.